Hello everybody, welcome to Coder Suggest, and today we are going to build a cart model in R. So cart is basically the full form or classification and regression trees. This R part is basically the library which is used to build a cart model. So I have already run this particular chunk, so I have just executed this line. So my these library is ready to use. And so now I'm basically setting out the working directory and reading out the data, and I will print the data also. So this is basically the data set, and it is a data set provided by a bank. So let us say that you are approached by a bank and they want to sell loans. So they want you to build a model to identify the potential respondents and those who do not respond so that they can save some cost. Okay, so here is the data set, and here is the columns which are like age, gender, balance, occupation, age bracket, and account type, account opening date, and total number of transactions, the debit transaction, the credit transactions, and transaction using mobile, and check transactions, and transactions through ATM. So these are basically all kind of data, and you have here, and you can see the flag also, that is has old loan, so and has nominee. So these are basically all about the data. And so we will go ahead with it, and we know that we have, as per the structure also, we know that certain of the features are as factors. Let us say the account type also, and certain other features also, those are as factors. So I have identified those, and I will simply go and convert them to factor. So flag has credit card, so we may know that if someone has a credit card, yes, no kind of an answer, so that is definitely a factor. Has nominee, yes, no, so definitely it is also a factor. So basically these are some initial steps that I am performing. So I have just converted these data or the columns which should be factor to a factor. So hang on until I prepare my data, and then we will build a cart model. Target is also whether someone will respond or not. So this is also a factor column, yes or no kind of scenario. And now let us say that before building any model, we will see that if it has any missing data. So fortunately, this data set does not have any missing data, so we have everything at 0 here. Now we will see that whether there are any constant variables or the redundant variables which we might have dropped. Okay, so I will simply apply a function that is length, and I'll print out the length of every particular feature. Okay, so we know that customer ID is a unique ID for every customer, and it should be dropped. It does not make any sense. Similarly, I'll see for random. This also does not make any sense, and this should be dropped. Okay, so this, you will get this idea once you have this data with you. And please do check out the links and in the description to get this code file. So now I will use the library deployer, and I'm not going to do a end-to-end EDA because the motive of this video is to get an idea of cart model. So just a simple thing, that I have written a deployer query to identify that uh, who should respond more. So here I have plotted the gender bar, and it seems that the males are more likely to respond than the females, and there are others also. But remember one thing, that this might be a tricky thing, because maybe actually you have less representation of females in your data set itself, and it might giving you a false idea that females are less likely to respond, because maybe you might have collected the data this way, that females are actually not that much as quantity. So do mention that also. You okay, do keep that in mind. So that is why I basically plotted this particular graph, that these graphs can also trick you sometimes. Now what I will do, that I will drop out the redundant variables. So here you can see that customer ID, age bracket, account opening date, and random. So these are kind of redundant variables because I don't think customer ID makes any sense. Age bracket I have dropped because we already have an age variable itself in the data set, so I will drop it out. Account opening date is something which I want to pay you attention, because account opening date is something the date itself does not make any sense, but if you want to make sense of it, then you can figure out or extract the years of account. So what I mean, that let us say that account opening date does contain the year also. So you may find out that how old an account is. So let us say that account opening date is 1/1/1970 and today is let us say 1/1/2020. Then you might extract the age gap, so you may come up with 50 years. So that may make some sense. That I leave on you, and you can try out with that. So basically for now I am just removing these columns. Now I'll see that what is the proportion of responders to non-responders in my data set. So you see that I have basically 87.4% are the person who are non-responders, and 12.56 are the responders. So certainly, as you might have expected, that the responders are in minority. Okay, so now I will go ahead and run the cell, and I will split the data set into train and test set. So basically, I'm using the library CA tools here, and CA tools is basically used to split the data set into equal ratio. So I have a separate video on that, on how to split your data set correctly in R. I will drop the link in the I button and in the description of this video. So please do not forget to check out that. That will be very much helpful. So now let me divide my data into train and test set, and you can see that 70% or 14,000 of my overall 20,000 records are in training and 6,000 are in testing. Okay, and 36 are my now columns or features remaining. Let us see the proportion of the target variable in both of the data set. So you can see that now I have actually an equal proportion of zeros and ones, or the responders and then non-responders, into my training and test set, and these are equal percentage. This is my training set, this is my test set, and this is an equal percentage. So you can see that CA tools has divided my data correctly. And now I will build a cart model. So now we are basically on the main topic, and here I want to pay your get your attention. So basically this is my training and test data, and just for some because I was intending to use this data again by using a random forest or neural network also. So that is why I have reassigned this data as training set cart and test set cart. So this is basically the same data which we divided and created earlier. I'm just reassigning it for the purpose of understanding. And these are basically the libraries which I'm using, the rpart, the rpart.plot, and rattle. So these are the libraries which I will use. Now here I'm setting the seed, and seed you need to set because every time you want to get the same kind of parameters to be set, or same, you if you want to reproduce your output, then you must use the seed. And our part has a parameter called control. So this is a requirement for if you want to build a cart model. And here also, just like if you might have used the random forest, then these term will be very much similar for you. So min split is basically how many minimum observations a particular node should contain in order to split. So let us say that after splitting, the new node formed has, if will be splitted only if it has 100 or more records. If it does not have, if it has less than 100 records, it will not be considered for further split. Min bucket equals to 10. So this is also a term which is used widely in to avoid overfitting. And what it does, that it basically tells you that how many observations should be there in your root node. So as many low you set it, you will basically go to overfitting your model. So let us say that I want to further reduce it, then it will start overfitting my model. Even at this point of time, I have basically set a very low number, and I am doing it deliberately because I want to grow the tree very deeply, and then we will prune it. So pruning is basically a very important technique, and basically you grow a tree to a higher length and then you cut it in the from the bottom. So let us say we will see how to cut it. So as of now, we are deliberately overfitting our decision tree, and xval equals to 10, and this is basically how many cross fold you want. So this is basically out of this total data, we are going to validate it into 10 cross fold. Okay, so basically we are creating 10 smaller samples from our data, and then we will keep testing it. So this is basically my xval. and you can check it also here. So if you want to understand what are all the parameters, you can go basically type out the command. Let me clear it with Control L, and you need to type out this question mark, and then you can type rpart. So this is the command, and if you will do like this, then in here in the help window you can see all the parameters, and here you can see everything about the R part. So here I was checking out, let us say you want to know what are the parameters of rpart.control. Then what you can do that, let us say I will type rpart.control, and here you can see that rpart.control has been opened for me. So these are the parameters: min split, max split, cp, and all those things are there. There are a lot of parameters which I do not need, and xval is number of cross validation, as I told you. So I want 10-fold cross validation. CP is basically main term here. CP is referred as complexity parameters. So this means that how error reduced per incremental node. So let us say you increment your tree by one more node. So let us say you grow your tree further, then each incrementing node or each newly created node reduces your error by what percentage. So this is basically this decides your complexity parameter, and it will all make sense when we will go further. So right now remember that I am deliberating creating a larger tree because I intend to prune it later. Okay, so now here is my cart model, and here I am writing the formula. Basically I am create this is my target variable, and I am using all the variables from my data set, and you should remember that I have already dropped some redundant variable. So now I'm basically building a model, and I'm saying that my target variable is this, and I want to consider all. So the dot is all the remaining data in my training set, and data I'm naming it training set card, which I just shown you here. And here method equals to class. Basically I want to predict the class, okay, that whether it is a 0 or it is a 1. And now I am providing this control parameter which I have set here. So this is my control parameter basically, and here I have mentioned all the features or all the parameters that on what basis should my model be split. So now it is printing out my model. So basically the model which I have built, and here if I show you, and if I show it to you, then let me just enlarge it. And here if you see that this is my root node, so you should also understand how to read this particular tree. That will be helpful for your interviews and for the understanding or elaboration. So you know that in my training set I have 14,000 records, okay. And out of 14,000 records I have 1758 as one, and this is basically these are your total records, and here it is your loss. So when I'm saying it is your loss, then what does it mean? It means that and basically first of all remember that this is the class which is predicted. If you built your tree only this much, then this is the class predicted. So you can see that actually at this node this is your loss. So basically this particular node has predicted that this is a zero class, and so in this particular at this particular label there were 1758 ones, and predicting it as zero, basically you have got an error, or you can say that you have lost all your 1758 records because these are ones and you have predicted as zero. So this is basically your loss. Okay, so remember this is your minority class, and this is basically your predicted class, and these are your total records, and this is your root node. Now this is basically a root node. So let us say the split has happened on the basis of the first split is done on the basis of number of dr transaction less than 5.5. Okay, and basically if I have it here, then number of LDR, what was the column name? Number of LDR transactions. So these are basically your debit transactions, which I believe to be. So let me just search it here. Okay, where is it? I think I have closed it. So don't worry, let me just give me a second. So number of debit transaction, number of LDR transaction, or number of debit transaction. So basically first split is happened on the basis of number of DR transactions less than 5.5. So let me open this particular output, and if you go down parallel, then you see that this is your node number 2. Okay, and if I scroll down and see at node number 3, then the parallel to this node is number of LDR transaction greater than 5.5. So that makes sense. You have three splits as yes or no. So number of DR transactions less than 5.5 goes to one side, your left hand side, and greater than 5.5 goes to right hand side. So this is your first split. Then this particular node is splitted, and the output you should read here, that it has total 8,370 records, out of which 772 is your loss. Why? Because these are the ones, these 772 were the ones, and since this particular node predicted all the classes at zero, reason being that 90% are the zero, so these are your loss because these are the ones and were predicted as zero. So this is how these are all the subnodes of here. And similarly, after 3, these are your right, and after 3, whatever is there, these are your right hand side. Okay, so this is how the T splits. First is this root, then the second, then second is splitted on this criteria. So you can just go ahead, and if you wonder how does this split happen, then I have a dedicated video on how a decision tree split basis on Gini index. That is a very simple video, and I have did the mathematics of all that through hand, and I have elaborated it very easily. So whichever variables gives you the highest Gini gain, the tree is splitted basis on that. Okay, so I will put the link of that particular video also in the I button and the description, so please do check out that, and this fundamental will be clear for you. Okay, so now let us go ahead, and we have built a large tree and we need to prune it. So this is my output, and if you want to and this is if you want to print out this particular tree, then you can fancy plot from our color viewer package, which I have just loaded above. And if you see here, then basically it is very small, and I think it is very hard to read. So what you can do, let me copy this particular line of code and let me plot it in the R studio. I have just put it here, and now I want to view it into my plot section. So you can see that here I can see it. And now if you want to view it, then export it and click on save as PDF. Okay, then you should click on preview. I don't want to save it, and here basically you can zoom it, so that is why I have opened it. And if you want to zoom it, you can press Ctrl plus, so you can see, and you can see the tree as the first split has happened, number of DR transaction less than 5.5. Here is your one, and then it has split it as flag has credit card or not. So these are basically your parallel node, and first it is happened on this particular yes and no, and then other nodes also. And here these are your uh, uh, leaf nodes or your terminal nodes, and you can see that the color has been changing gradually, and this the blue ones are your ones. So these are the leaf nodes that have predicted something as one. Okay, so this is how you can just go ahead and see and make some sense of it. For the sake of saving some time, I am going ahead and basically uh, above, when I was building the model, I showed you one thing, that was the CP, that was a parameter, and I told that this is my, let me just collapse this particular output. And here I said that CP is the percentage error reduction with each incremental node. So if you want to print the CP at each level, then here is something. And okay, I think I have just, okay, so here if I will print CP, then this is a command, and this basically tells me that what are the actually variables are, those are used in tree construction. So these are the variables. And root error node, so root error node is basically there were 17581 ones, and out of 14,000. So since 0 is way in majority, this is the error actually. And you can, as I displayed you also, that all my these ones are classified as zeros because 0 is in majority. So 12.557 is my root error node, or all my data or all my ones are left. CP is something that, as I told you, is the complexity parameter, and here is the cross validation error. So how do we choose an optimal CP? And because what happens that if you grow a tree infinitely, then CP will keep decreasing and it will be negligible and will not be of any use, and your tree will, and this will happen on the training data, and CP will keep going down, going down, going down. And what will happen that the same train test scenario as we encounter in any other machine learning model, that the error might, you might be getting an overfitted model, that the error might be getting reduced on your training data, but when you will take this model to the testing data, it will fail. So we will choose a CP value that has the lowest cross validation error, and I hope you all are familiar with the cross validation. So basically we will choose the particular CP value which will give us the lowest cross validation error, and we will prune the tree basis on that. Okay, so pruning is again very simple. So here I am basically getting out of this table I have created, where I have created cross the CP, I have printed the CP. I'm basically getting the CP value which is giving me the minimum cross validation error, and based on that, as I just told you, based on that we will prune it. So I am writing this particular table. So I am cart model does contain a CP table, and if you want to see, then you can also type it here, that cart model.cp table. So this is just what was printed earlier. Okay, so I will extract the minimum value here, the minimum value of a cross validation error, and that will be my best CP. So here I am saying that out of my CP table, give me the CP value which has the lowest cross validation error. So this is basically the command. I'm writing which.min and I'm providing my parameters. So I'm saying that whichever CP value gives me the lowest cross validation error, give me that CP value, and I'm storing into best CP. And basically prune is the command, and it is a part of rpart. So basically pruning, I am basically giving the best CP here, and I am basically pruning my overfitted tree on the basis of that. So basically I am basically cutting down my tree from the below, and now I can see that this is my prune tree. Okay, so you can just go ahead and have a look at that. So I'm not doing that right now because that will make this video very long. So if you want to print the CP of prune model, you can do it from here also. And this is also one thing. Okay. And your root level error will remain same, because at the root level, actually the records are same. At the root level, you have 1758 records as one and out of 14,000. So that will remain same. We are pruning the tree from the below. So now we have built a model. So now what is the time? That now the time is for prediction. So we have built a model, and now we are wanting to predict, or like we are going to predict on that. So I am saying that threshold as 0.5, and this is generally the conventional threshold, that if the probability of something is greater than 0.5, it should be considered in 0. If greater than 0.5, then 1. If less than 0.5, then 0. So here I am basically I am creating a score also. So this score is my probability, and this class is my actual class. And here I am saying that if the predicted score is greater than threshold. So here I'm setting out the threshold. If the predicted probability is greater than my threshold, then predicted as 1. Otherwise, say this is a class 0. Okay. So now I'm basically printing out this particular this particular uh, table. So this is actually now not relevant. So this is my, you can say, my confusion matrix here. And if I talk about what is the accuracy, overall accuracy, then you can see that basically uh, 0, this is my predicted class, and this is actually 0. So these are 0 and are predicted 0 also. So 1190 plus, you can say that, and these are my ones which are also predicted 1 by my model. So these are also my correct predictions. So these are, okay, sorry, 11998 plus 434. So these plus these. So these are my diagonal, and these are predicted correctly. These are 0 and also predicted 0. These are actually 1 and also predicted as 1 by my class. So these are basically my how many records are these? So out of 14,000, my 1, 2, 4, 3, 2 are predicted correctly. So 88.8% is my overall accuracy. But if we see at the ones, then you see that out of how many ones did we have? 1, 3, 2, 4 plus 4, 3, 4. So these are my actual ones. Okay, so these are the total number of ones in my training data, and those are essentially 1758. So out of 1758, how many are predicted correctly by my model? So you can see that this is my predicted class. So you can see that out of overall 1758 records, my model has only predicted 434 as ones. It has incorrectly predicted, out of those 1758, it has incorrectly predicted 1324 as zeros. So that is something, if I talk about, then 434 divided by 1758, so that is only 24.6%. So you can see that my model has gone terribly wrong on predicting the one class. Now I will tell you why it went wrong and how you can what you can do to get this thing right or increase your recall. What we say here, that these records are actually, my recall is very low. Okay, so now I will print out the model performance. I will use the library caret, and I will print out the precision, recall, and all those things here. So let me run this. So you can see here that my recall is predicted as 24.68. That is what I just displayed you also, that my recall is 24.68. So these are actually, recall is your one of your important matrices that tells you that out of your actual positive, how many your model has predicted positive. So these are very important in the medical and the loans, where depends on the scenario, we have precision recall. So let me print out the overall summary, and my precision is 64.64%, but my recall is terribly low. It is 24.68%. And why it is so, we will see that in a moment. And here my true negative rate is also printed out, and prediction on the test data is also something that I have done on the test set also. And here I am basically printing out my uh, overall scenario. So you can see that recall or is again very low, so it is 19.2%. And basically this is something that we need to pay attention. If we go by this model, then we might have been getting an excellent accuracy of 88 to 89%. But remember that we are basically predicting our ones at zero, so our model is not performing well in that scenario. So now what can you do? So the question arises that what can you do? So first thing first, as you can see, as I displayed you at the earlier, if you might have paid attention to, then let me go back there again, and let me show you what I mean. So just bear with me for a moment. And here, if I show you, and yeah, here, so you can see that our ones are way in minority. So only 12.5% are the ones of my total 20,000 records. So that is something you first need to pay attention. So basically the data should be a balanced data, and this data, in this data, the one is fairly in minority. Second thing is, the decision trees are not very much suitable for such kind of scenarios. Why? Because decision trees are basically, what I mean here is not a decision tree. Basically a single decision tree or cart like models are not suitable. You can build a random forest kind of model where you have an ensemble of decision tree. So here pay attention that what is different in cart and random forest is that cart is a single decision tree. You see that we printed a decision tree. Random forest, you built multiple decision trees like this, and then you take an average of all the outputs of all decision trees, and then you decide that what is your actual class. So first thing is that what you can do is that first you can try the oversampling and undersampling technique, and either increase the amount of ones or suppress the amount of zero. So try to make it a balanced data set, first thing. Second thing you can do is try a technique like random forest and ensemble modeling technique. And first and other thing is that you can do some feature selection and try out that what are the best features. So I did some feature selection technique earlier, and I found out that a part of those which are dropped all seems to be important. Again, you can also try that, and you can do not forget, please do not forget to let me know in the comments that what has been your accuracy. So this is all about the decision tree model, the cart model, and I hope you will find this video helpful. Please do not forget to like this video and subscribe to my YouTube channel, and I will see you in another video. Hope you have liked this. Thank you very much.